Okay, AP Calculus AB, Unit 4, Day 5 warm-up. And there's 3 problems. So try all 3 of those. Number 3, you don't know the derivative of tangent yet, but I'm gonna actually show you guys how to do that one. So I mean, you could see if you can guess what you think it is, but then we'll do it together. But 1 and 2, I want you to try. They're both based off the idea that those limits aren't just any other limit; those are derivative limits. So number 1, I want you to try and do it the short way and the long way. Okay, the short way would be taking advantage of what you see. The long way would be doing it all the way out, Pascal's triangle probably. So try those. Pause the video, and then I will talk about how to do these. Okay, assuming you've tried these, it's just one more chance for you to get good at something that's going to be on your test, next test. The answer to this problem is 32. Okay, now we're going to do it the long way first. So the long way is actually saying, well, if I plug h equals 0 in, I'm going to get 0 over 0. So let's see if we can try and get the whole out of it. We could also do L'Hopital's rule, but I'm not going to do that yet. The long way is let's actually expand the binomial and see if we can factor the whole out. So you're probably going to want to use like a Pascal's triangle, which should be easy to recreate real quick. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. This is the one we want. This is the 0th power, first, second, third, fourth. The second number should match the power. That's one we want. So we're going to put this in. We're going to put, okay, we're going to say, okay, 2 plus h, wait, hold on. So it's going to be 1 times 2 to the 4th, h to the 0, plus 4 times 2 to the 3rd, h to the 1st, plus 6 times 2 to the 2nd, h squared. So remember, the first term starts at the high power, and the second term starts at the 0th power. And this one gradually comes down, 4, 3, 2, 1, all the way to 0. This one goes up from 0, 1, 2, 3. Okay. Plus 4 times 2 to the 1st, h cubed, plus 1 times 2 to the 0, h to the 4th. And then you have a minus 2 to the 4th just from that. All over h. We're still taking the limit. Let's try and clean this up. Now, hopefully, for this to work, all the terms that don't have h's should drop out. So here's a 2 to the 4th, that's a 1. This is 2 to the 4th, which is 16. And there's a minus 16 over here. They cancel each other out. I think everything else stays. Now, what I'm going to do is I'm going to factor an h out of everything on the top and the bottom to get rid of the whole. So if I factor an h out, this is going to be 4 times 8 is 32. Plus 24h plus 8h squared plus h cubed all over h. And then the whole is going to cancel out. And then if you plug 0 in, all the terms with h's cancel out, and you're just left with 32. So I'm gonna make you guys do that on your next test for one problem, just once. Okay, but if this was the actual AP test, you wouldn't do this because you only have like 2 minutes to do it. So if you only have 2 minutes to do it, what you should do is you should, oh, that's a derivative of x to the 4th. And then I'm going to take the derivative of that using the rule I've memorized, 4x cubed. And then I'm going to plug 2 into that. And 4 times 8 is 32. So that's the quick way, which I do want you to use whenever I allow you to do it, because it's definitely worth it. The other option was doing L'Hopital's rule, which is not what I was really looking for here, but it is 0 over 0. So we could do the limit as h goes to 0 at the derivative of the top. Now the derivative of the top is going to be 4 times 2 plus h to the 3rd power. So it's power rule, but it involves some other stuff we haven't talked about. And then you got to multiply by the derivative of what's inside, which is 1. The derivative of 16 is 0. The derivative of the bottom is 1. If I plug h equals 0 in here, what do I get? 4 times 2 cubed. 4 times 8 is 32. Got the same answer. But you're going to need to be able to do it the long way on your next test. You're going to want to do the short way too. Now, the next problem is absolute value. So this is a derivative, and you might be like, okay, we're trying to take the derivative of the absolute value of x at 3. So then we're going to find the derivative, whatever it is, and then we're going to plug 3 into it to find our final answer. Now, what's the derivative of absolute value? Well, one, I haven't taught it to you. Two, there isn't really. To write it would be a little more complicated. What you would have to do if you wanted to do it is you'd have to rewrite it as a piecewise function. When x is greater than or equal to 0, then the function is just equal to x. When x is negative, you get the negative of x. So then you could take the piecewise derivative, and it would be 1 for x is greater than 0 and negative 1 for x is less than 0. So then you could plug 3 into this and be like, okay, that's going to be 1. So you could do it like that, but I don't recommend that. I think that's harder than it has to be. What I would do is I'd be like, hey, I know what this looks like. This is a V graph, right? Right? Is that what this graph, the absolute value looks like? You guys learned this in Algebra 1. And I want the slope at 3. What's the slope right here? Right? That's what we're trying to figure out. Well, the slope, that's 1. Done. Now I need some work. So it's either this or it's all of this. Okay? But I would draw the graph. Okay, number 3, you really probably shouldn't have had any shot on. Prove tangent. Well, first of all, what we've usually been doing in this class, what I usually do is I think of it as sine over cosine. Because I don't want to memorize a bunch of extra stuff for tangent, secant, cosecant, cotangent. I just want to memorize everything about sine and cosine, which usually pays off. Now, to take the derivative of a fraction, that's going to involve another rule that I haven't taught you yet. So I'm going to go and show you what this rule is. I don't think we're going to really use it in this chapter. We'll probably start using it next chapter fully. But hey, this is your intro. So if you're taking the derivative of a fraction, the derivative equals. There's this thing, I don't know, if you took pre-calc, you might have been shown this. Low d high minus high d low all over low squared. And that's just a little cute saying, which I'm usually very anti-cute sayings, in math to remember things. But it works, and I feel like this is an easy one to mess up. So let me write it out. Low d high, so you're not going to ever write this out, but this is just low d high minus high d low all over low squared. And if you want to get really cute, which some teachers teach it like this, all over low squared we go. That's the extra cute part. All over low squared we go. All right. Now the d's represent derivatives. Okay, and the low means the denominator, and the high means the numerator. Okay, it just rolls off your tongue a little better. Low d high minus high d low, all of low squared. So in this case right here, the derivative of this is going to be low d high, the derivative sign we learned was cosine, low d high minus high d low, the derivative cosine is negative sign we learned the other day, all over low squared, which I usually put in parentheses. I usually use a lot of parentheses on this because it's usually multiple terms and it's super easy to make little mistakes. Now, if we clean this up, it gives us cosine squared plus sine squared all over cosine squared. And usually you write the squareds right here on, trig, right? Anything special about that? What's cosine squared plus sine squared? Oh, that's a Pythagorean trig identity. Sine squared plus cosine squared always equals 1. Right? Okay, what's another way of writing that? 1 over cosine squared. Secant squared. So the derivative of tangent is secant squared. Now, I don't think you're going to need this for this chapter, but I'm just throwing it out there. Next chapter for sure. Now, what do you think? Do you think it's worth just remembering sine and cosine and doing all this work every single time? No, this is worth memorizing. So we are going to, when it comes to derivatives of all the weird trig functions, tangent, cotangent, secant, cosecant, we're going to memorize them because it's just too much work to recreate them every time. We could, but it's worth memorizing. A lot of times I just, I avoid memorizing things that it's not going to benefit me that much. But there you go.